In this video, we're going to go over the characteristics of the inverse tangent function. So here on the left, we're given the graph, the parent function of tangent of x. So over what interval does y equals tan of x take on its full range of values? All right. So if we look on the graph here, right, from negative pi over 2 to pi over 2, that's kind of like our parent function for tangent that we look at. And we can see that it's essentially going from negative infinity to infinity, right? This Saturday Night Fever shape in between negative pi over 2 to pi over 2. And that's technically where we have our full range of values, negative pi over 2 to pi over 2. Or we could say, from pi over 2 to 3 pi over 2, but this is kind of the default answer, okay? Over what interval is y equals tan of x 1 to 1? Well, remember, it has to pass a horizontal line test, and that's also over that same interval, negative pi over 2 to pi over 2. What should we restrict the domain to in order to create tangent inverse function? Well, that, using the answers from 1 and 2, we will restrict the domain of y equals tan x to negative pi over 2 to pi over 2 as well, okay, to create inverse tan function, okay? So let's see what the inverse tangent function looks like. So using your knowledge of inverses to graph, use your knowledge of inverses to graph y equals tan inverse from y equals tan of x. Okay, so we're going to fill in the table of values for tangent, okay, from negative pi over 2 to pi over 2. So negative pi over 2, we know that it's going to be undefined, right? They're a vertical asymptote at negative pi over 2. And then we'll go from there, we'll go negative pi over 6, negative radical 3, right? Because we're in quadrant 4. Negative pi over 4, negative 1, negative pi over 6, negative radical 3 over 3, 0, 0, pi over 6, radical 3 over 3, pi over 4, 1, pi over 3, radical 3. And then at pi over 2, we would have another vertical asymptote. So it's undefined there. Okay. So our domain, our original domain for tangent was all real numbers except x cannot equal pi over 2 plus n pi, right? That was from the previous Jamboard where we talked about the restrictions to the domain, all right? And the range we had was all real numbers, right? It was negative infinity to infinity. Because again, it kind of looked like this backward Saturday Night Fever function. So it's going down to negative infinity and up to positive infinity in between our vertical asymptotes, right? But so remember, for our inverse functions, right, we would switch the inputs and outputs. So for arctan, we would have, therefore, it's going to be undefined, and we'll have negative pi over 2, negative radical 3, negative pi over 6, negative 1, negative pi over 4, negative radical 3 over 3, negative pi over 6, 0, 0 stays the same, radical 3 over 3, pi over 6, 1, pi over 4, radical 3, pi over 3, and then undefined at pi over 2. So what does that mean in terms of the graph of arctan? Instead of there being vertical asymptotes at negative pi over 2 and pi over 2, we're going to actually have horizontal asymptotes at pi over 2 and negative pi over 2. So pi over 2, so it's about 1, 2, 1, 2, negative 1, negative 2, like that. So 1 pi over 2 and negative pi over 2 is a little bit more than 1.5, right? So it's about, oops, it's a little bit lower than that. So maybe about here. And then 1.5 again, somewhere around there. Okay. All right, so those are our horizontal asymptotes for our tangent function. And then let's do negative 1, positive 1, pi over 4. So it's about 0.75. So it's about like maybe about, let's do around there. 0, 0 is easy. And then positive 1, positive pi over 4. So it's a little under 1, like that. And it's kind of going to look like a backwards S. Or not backwards S, it kind of like a regular S like this, but it's a little bit flatter. Okay, so our domain for arctan, we could plug in any number we want. It's going to be negative infinity to infinity, but our range is going to be limited to negative pi over 2 to pi over 2 and open parentheses on both, right? So basically our output of answers is going to be limited to just negative pi over 2 to pi over 2. And again, how does the domain and range compare with tangent? The domain and ranges of tan inverse are interchanged with tan. So that's our summary of the tan inverse or inverse tangent function. And if we look at, I think it's slide 7, this goes over all of the major characteristics as well.